Okay, the amplifier is on now. All of the tubes are in their sockets. It is set up as it normally would be. Uh, the tone controls are all at about the 12 o'clock position. I've actually got the reverb turned off just because I don't suspect a problem with that circuit at this point. So one of the things you can do with tube amps is go through and determine in what condition the tubes are. The power output tubes, these are EL84s, those will eventually go bad, and in Blues Juniors they're pretty infamous for that because they tend to run the bias current pretty hot on the power tubes. When those go bad, you'll hear it when you're playing. The sound will get very kind of muddy and ratty, and there won't be a lot of definition. It just won't sound very good. You'll know that the power tubes are bad, and you just swap them out and the sound quality will get much better. With the preamp tubes, it can be sonic effects that you hear when you're playing, but you may not necessarily realize right away that it's the tube. So that's why, to check pre-tubes, one of the things we can do is you go through and tap on the tubes, because pre-tubes will do a thing called going microphonic, and I'll show you what that sounds like right here. But when a pre-tube goes microphonic, it will still make noise. You will still be able to play through the amp, but the sound quality will be not as good, and it just means it's time to replace the pre-tube. So with this amplifier, I suspected some problems, so I went through right away and did the tube tap test. You want to use something insulated for poking around in a guitar amp like that. This isn't necessarily an insulated tool, but it is a plain, unpainted drumstick, which is wood. It's, for most purposes, pretty well insulated. So we'll go through and tap the tubes and listen to what we get here. Oh, and for this test, I've got the volume turned up pretty loud. So this has a master volume and a regular volume. Those are both turned up pretty good, because you want to hear what's going on. Okay, picking up a little noise there from the speaker. Picking up more noise there from the speaker. Definitely a problem here. That's really sensitive. So, I'll cut to the chase on this one. I had thought that I had a bad pre-tube there. So, one of the things you can do is just swap the tubes. And I swapped through the 312AX7s here and found that this tube position is where the problem is. It wasn't the tube. So when I moved the tube to other positions, that tube didn't seem to be microphonic anymore. It only seemed to be the tube in this first position. So then I start to suspect the tube socket. So something must be bad with the connection to the tube socket. So I took out this board back here. There's a small printed circuit board that's mounted to the back of this chassis, which all of these tube sockets are soldered to. Well, one of the culprits can often be what they call a cold solder joint, which is basically a bad solder joint that connects the tube socket to the circuit board. So I went through and resoldered or re-wetted all of the solder on all of the tube sockets, and I can show that in another video, but it's pretty simple. You just go through with some clean solder and re-wet the solder. One of the things I do like to do is actually use a solder braid or a desoldering braid and pull the original solder off and then resolder it with fresh solder, and I did do that. A couple of things to note were that the first two preamp tube sockets here, they had already been resoldered at some point in time. The third preamp tube socket had not been, and the power amp tube sockets had not been resoldered. The power amp tube sockets, the solder was in such bad condition on this amp that you could actually see cracking in the solder where the tube sockets solder to the printed circuit board. This is one of the things, is a highly controversial topic with electronics designers and guitar amp manufacturers and guitarists themselves. It's the old point-to-point wiring versus printed circuit board debate. I don't think I'm going to wade into that debate too heavily at this point, but what I will say is there are a few things we know about this amp in particular, but also many other guitar amps like it. because the speaker is mounted to the same chassis as the rest of the amplifier here, there's no doubt that vibration from the speaker, normal vibration when you're playing, is transmitted through the chassis, through the cabinet and the chassis. So all of the electronics in here do experience vibration when you're playing. All of the tubes experience vibration when you're playing. All of the tubes also experience vibration anytime you move this thing around. Every time you pick it up and set it down or bump into a doorway when you're carrying this thing around, these tubes are going to vibrate. So we know that there is going to be there are going to be mechanical effects on this over the years. They're just going to be. In fact, that's part of why Fender included this little piece of channel here with the springs to kind of hold the power tubes in place, because as they move and vibrate and heat up and cool down and all the things that they do, you know, these can start to work their way out of the tube sockets. So there are going to be effects of that here. One of the things that I find to be somewhat unfortunate in this amp is that these PCB mounted tube sockets don't have any means of mechanical support other than the pins that are soldered into the circuit board. So if you think back on your preferred circuit design techniques, and you think back on your proper soldering procedures, it's essentially a well-established metric or a well-established standard that you do not use solder alone to support a mechanical connection, or you do not put mechanical strain on a solder connection. Solder is there to hold the electrons together. It's to help the circuit, you know, it completes the circuit. It allows the path for the electrons to flow. But if there's going to be mechanical strain on something, there should be an additional means of supporting that. So a standard tube socket would actually be screwed to the chassis in, say, like an old, you know, an old guitar amp or an old radio or anything like that. You take it apart and you'll see that the tube sockets are actually screwed to the chassis, and then the wires are just soldered to the tube sockets. So I think I've said enough about that. That's why the solder goes bad on these. It's pretty common. Re-wet the solder or re-solder the sockets. A lot of times that'll fix a lot of issues. So I did that, and in this case it didn't fix everything. So I realized, well, we've got something further going on here. It's not the tube, and I don't believe it's the tube socket because I resoldered that. So then you start to move the tap test into the amplifier. As I said, there's relatively high voltages in here, so be very, very careful. But you'll notice we had this first pre-tube, very, very sensitive. So we go to this wiring. This tube plugs into this socket, which is soldered to this PC board, and then the PC board, there's really no electronics on the PC board. It's just a conduction path into the amplifier. So the circuit for the tube is actually carried on this ribbon conductor here. So watch what happens when I tap that. Right there. That second conductor from the end. There's definitely something bad going on with that conductor. So I've narrowed it down to this ribbon conductor from the main circuit board to the tube socket circuit board. I'm pretty sure there's either a broken conductor in here or there's a bad connection to the boards. I did have both the tube socket PC board out and I had the main circuit board out when I was resoldering, and I didn't happen to see bad solder where the ribbon cable connects to the circuit boards. So I don't think it's bad solder. I did resolder this end just for good measure, but it didn't make any difference. So I believe we've got a broken conductor in there. This, like I said, this amp had been apart before I got it to resolder some of the sockets, and then I took it apart again to resolder some of the sockets. I've also taken the board out, the main board out before, just to do different things. I was testing some points on the preamp board and stuff, and Oh, and another thing was replacing the input jack, which it's very, very common for the factory plastic input jack to fail on these. So anyway, the board has been out of this amp a couple of times in the past, and every time you take it apart, it's really hard on those cables. So what I believe has happened here is over time this cable is, this conductor, second conductor in the ribbon cable, has broken. So I'm going to take this out completely, and I'm just going to reconnect the tube PC board to the main board with individual conductors. Something you want to be aware of, a couple of those conductors are going to have something like 250 volts on them because they're the tube plate supply for that tube. So you want to be careful with the ones that are going to have the higher voltage on them. Make sure that you don't nick the insulation when you're stripping the wire or installing it. You want to make sure that it doesn't somehow get close to any of the other components and short out or do anything bad like that. So be aware of which ones are supplying the tube plates, and just be mindful that they're 250 volts. You don't want them intermingling with other things that shouldn't have 250 volts on them. One more consideration about this, like I said, I think I'll do a filter capacitor upgrade. Maybe do an upgrade to all of the electrolytic capacitors while I'm in there. A lot of people on the forums and on YouTube have suggested that does help. It's definitely worth a try. When you do that, you want to make sure to buy high quality capacitors. There's absolutely no point in putting low quality capacitors in place of these factory ones. Definitely get something that you can trust. Electrolytic capacitors have become a very, very controversial subject in the electronics world lately. They are a failure point. Eventually electrolytic capacitors will fail, and they also now have been the subject of some counterfeit electronics parts. So there have been some electrolytic capacitors that had branding from some of the very big, well-known capacitor manufacturers that should have been very high quality, very reliable capacitors, but they weren't. They were counterfeited. They came from a very low quality manufacturing facility, and they were counterfeited as high quality parts. So you need to make sure what you're putting in there really is good. One last thought on this. Since I'm going to be going in and replacing this wiring, I am considering putting standard style tube sockets in the chassis, types that actually screw into the chassis. That means I'll have to remove the PC board, put the sockets in, mark them and drill them, and then screw them to the chassis, and then resolder to all of the tube sockets. So I really don't want this amp to be taken apart for a long time. I use this amp whenever I play. It's something that I don't want it to turn into a project that sits on a bench for the next 9 months. So we'll see what I do. If I get really ambitious, we'll put the new sockets in and rewire all of them. If not, we'll just bridge across where this conductor has failed. Thanks for watching.